So this video is going to pick up where our last one dropped off, and that is with the electron configurations for the first 21 elements. Okay, so we just finished up element number 14, which is our silicon, and we filled in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 electrons here. You wrote 1s2, 2s2, 2p6, 3s2, 3p2. That all adds up to 14 electrons. And this is where this model starts to get a little crazy. I'm going to continue with it because some people like to have that additional visual for you. Okay? But what we're going to see is we're going to pick up with element number 15, which is our phosphorus. And phosphorus has 15 electrons. So we're going to put in 15 electrons according to the off-ball principle, which is going to have the lowest energy down at the bottom and the highest energy up at the top. And we're going to fill in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, spreading out our electrons first according to Hund's rule. 11, 12, 13, 14, 15 electrons into the last orbital in 3p. And I write 1s2, 2s2, 2p6, 3s2, 3p, 3p3. Come on. There we go. 3p3. And what I have over here is my nucleus in the center. Then I have the 1s orbital with 2 electrons in it. Then I have the 2s orbital with 2 electrons somewhere in it. Then I have the 2p, there's 3 orbitals. And I have 1, 2, 3, 4, 5, 6 electrons in there. Then I have the 3s orbital with 2 electrons in it. And then I have the 3p orbitals, 1, 2, 3, with 3 electrons in each one. Okay, so number 16, good old sulfur. Where does the 16th electron go? 1s2, 2s2, 2p6, 3s2. 3p can still hold 3 more electrons. So here's where I double up, and I put my first one doubled up according to Hund's rule in that first spot. And I write 1s2, 2s2, 2p6, 3s2, 3p4. So then I find this first electron orbital and the 3p, and I double it up in there. Number 17 is going to be chlorine, and I'm going to put my 17th electron, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And I'm going to write it right here. 1s2, 2s2, 2p6, 3s2, 3p5. Do I have all 17 electrons? Let's make sure. 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 5 is going to be my 17 electrons. All right, what is argon going to do? Argon is going to put my 18th electron right here at the end. And I'm going to write 1s2, 2s2, 2p6, 3s2, 3p6. And I fill in my electrons. Oop, I didn't put it in the last one. Here and here. All right, so now that my 3p is full, where does number 19 go? Well, what's the next lowest position? Okay, 1s, then 2s, then 2p, then 3s, then 3p, then there is the 4s. And here's where you really start to see the layering. 1s2, then the 2s2, then the 2p6, 3s2, 3p6, then in the 4s there is 1. And if you add up all of these numbers up here, that gives us 19 electrons. So if we go back to this drawing, this is where I have my 4s layer, and then I put in 1 electron somewhere in there. The reason why we use this and this instead of a three-dimensional picture is just because we can be more clear. Okay, we're not overlapping with our lines and stuff like that. And then we have number 20. So where do I put my 20th electron? I put my 20th electron in the next lowest spot, which is right here in the 4s. And I write 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. And then I can account for all 20. So you should pretty much get the idea right now that we keep on adding on to the subsequent electrons, ogres, onions, layers, gobstoppers. So let's see if we can solidify it with scandium, number 21. So where does my 21st electron go? Okay, 4s is full. What's the next lowest layer? The next lowest layer is 3d. So I put my next electron there. And I write 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. And I count up 2, 4, 10, 12, 18, 20, 21 electrons all right here. So the real reason why we don't draw a three-dimensional one is because the d orbital, remember, is double dumbbell, and that would be just a nightmare to put an electron somewhere in there. All right, so those are our electron configurations. And what you'll see here on this slide is all the different elements, 1, 2, all the way down to 18. And you can see how we keep adding on to each one of them. 1, 2, 3, 4, 5, 6. Then we add 1, 2s, 1, 2, 3, 4, 5, 6. Yes, there are patterns where all of these things start adding on to one another. Okay, a good representation for these is seeing these two websites here. So you'll see that the orbitals are going to be all kinds of three-dimensional ones. Let's see if I can move this over a little bit. And basically what we're doing here, whoops, I don't want to do that, is we are adding a 1s orbital over top of this, and I'm going to make it mesh so you can see it inside and you can spin it all around. Then we're going to put the 2s orbital over top of it. I'm going to make it mesh so you can see inside. Then comes the 2p orbital, and you can see that like so. Then the 2px, so here's 2py. Come on, you can do it. Yay, like so. And then we can do the 2pz orbital as it loads, and you can see that all right there. And then after that is the 3s orbital. Okay, I'm going to turn that into a mesh, and you can see how it's just layer upon layer upon layer of each one. And then we start getting into the 3px orbital. And here's your dumbbell shape for that. 3py. Okay, and these layers upon layer, 3pz. And then we're going to put the 4s on top of it. Okay, so layer after layer after layer after layer. Okay, and the further that you get out, you end up seeing that these guys um, end up having all these different orbitals that we view. Stop these pop-ups. Um, and it's not working for me, but I will link it in our slides, and you can see how all those guys end up working. So those are our awesome websites that we are going to use.